Okay, guys, this is my second guess, my second gut feeling. The second question could be kind of complex number question. Especially in the complex number question, there can be such a things, right? A g to the power of n plus 1 over g to the power of n. Those application. Or another one can be like cosine theta plus I sine theta to the power of n, the expansion. Okay, I'll go over one by one. For example, the first one is g to the power of n plus 1 over g to the power of n. What can be the example of that one? I'll take the, oops, where is it? Example. That can be that example. Yeah, where can be the example? It could be, yeah, I take the example from 577. I won't solve all the things from 577, but anyway, this would be the example. Basically, I believe you all know, once we calculate g to the power of n plus, this one is actually 1 over g to the power of n, right? Once we add those two, then it will go for the real number. This is actually real, right? By using this property, we can get like a cosine to the power of 4 or something like that. Let me show you one example. Okay, one calculation like this: g to the power of n, g plus 1 over g to the power of 4. Then it will go for 4, 6, 4, and then 1 over g to the power of 4. Maybe combine similar thing together here, like then, and then we use the formula that this one is 2 cosine theta to the power of 4, and then this one is 2 cosine 4 theta, right, plus 4 times 2 cosine 2 theta plus 6. Then we can have cosine theta to the power of 4 goes to 1 over 8. Then what is that? The answer for this is 16, or 1 over 2, is it? Plus 3 over 8. Then what is used for the expression? Then we can do the integration. Everything is linearized so-called. Then we can go for the integration, right? So definitely, I won't say, if you resolve this equation, then definitely the next question is calculate this one, right? It can be to the power of 4, it can be to the power of 6, it can be to the power of 8, or whatever. Yeah, there can be those kind of questions. And then for the rest of the questions, yeah, you can check actually G number 2. For this question, what you need to do is you need to check what is the pattern for this answer of integration. Everything will go for the sign except the last one, right? So that once you do the what was that, the so-called the definite integral, only the remaining part is this one. All the rest go or the rest terms going to the 0 because everything goes to be sine, right? Sine pi, sine 2 pi, sine 4 pi, something like that. So every term goes to be 0 except just the last one. Something like that. Okay, that is the first example. So g plus 1 over g to the power of 4. And then the another example can be the next question, I think. Yeah, if we use the next example, what I can explain to you is instead of using g plus 1 over g this time, yeah, we just directly expand the cis theta. So for example, in order to get the cosine 5 theta, yeah, cosine cis theta to the power of 5, it can be cosine theta plus I sine theta to the power of 5, right? Then we can use binomial expansion, which means cosine theta to the power of 5 times 5 plus 5 times cosine theta to the power of 4 I sine theta plus 10 cosine theta to the power of 3 I sine theta squared plus blah blah blah, right? And then we can go for this is 5 theta, right? We compare rear versus rear, then we can get the answer cosine 5 theta goes to be 16 cosine theta to the power of 5 plus blah blah blah. We can get this result. What is the purpose used for this expansion is like, okay, for example, okay, let's think about to solve this expression to go for 0 equation like this number e question. Then cosine 5 theta goes to be 0, which means 5 theta can be pi over 2, 3 pi over 2, 5 pi, 5 pi over 2, something like that, right? And then we can solve these like 16 cosine theta to the power of 5. After that, what is that? Minus 20 plus 5. Minus 20 cosine theta to the power of 3 plus 5 cosine theta goes to be 0. Then we can solve this as an equation about the cosine theta, right? Then we have the answers cosine theta. Actually, that can be 0 and then something, 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 because that is the fourth. This is the equation, quadratic equation of cosine theta squared, right? So that the answer form goes to be something like that. So there can be 5 solutions from this equation, right? And then there should be 5 solutions. Sorry, there can be 5 solutions from this left hand side, cosine 5 theta to be 0, right? Then from here, theta goes to be pi over 10, 3 pi over 10, blah blah blah, 9 pi over 10. Yeah, we have 5 theta values, right? Then we put the cosine on top of this theta, then cosine theta goes to be cosine pi over 10, cosine 3 pi over 10, blah blah blah, right? And then here we have also 5 roots, and then here we have, including 0, we have 5 roots, 5 solutions, right? Then compare one by one, then we can decide what is the exact value of cosine pi over 10, 3 pi over 10, all those things. That can be another question. One more example I can give you here is this one. This is the last example from my gut feeling. Okay, the question say that the first solve nth root question, right? I don't want to go over this nth root question solution today because I have shown to you already so many times. This is I said this is pattern question, and then starting with the assumption of g goes to be r c theta, right? And then k goes to be 0, 1, 2, something like that. Okay, that is the first question. But another question is, okay, g to the power of 7 minus 1 goes to be 0. Once we factorize these, since this is sixth order polynomial equation, so that we can factor this by 3 quadratic factors, right? And then from the result of nth root question, we know that all the solutions are okay. Here we have 1, 1, 2, 3, another 1, 2, 3, and then all those roots are actually x-axis symmetric position, right? Once this is okay, let's say this is the one of the solution, the omega, then this one is omega conjugate, and then 1 over omega, and then this is omega to the power of 6. And then let's say this is omega squared, then this one is omega to the power of 5, that is 1 over omega squared, or that is omega to the omega squared conjugate, something like that, right? So if we take the roots from one from top and then one from bottom, like, okay, so that take two roots as omega and omega to the power of 6, which is 1 over omega or omega conjugate, then we can decide the quadratic expression. Why? Once we add those two, then there is adding conjugate, so that there is cosine theta. Actually, in this case, theta is 2 pi over 7, which is the smallest positive argument of one of the roots here. Okay? And then the multiplication, we have 1, because omega to the power of 7 is 1, right? Then we can make the quadratic equation, which is g squared minus 2 cosine theta g plus 1. That is one of these quadratic factor, right? So instead of theta, okay, I can write here cosine 2 pi over 7, right? The rest two, since we will take omega squared, and then omega to the power of 3 as our roots, one of the roots, omega squared, and then together with omega to the power of 5, omega cubed together with omega to the power of 4. Then the other two factors can be g squared minus 2 cosine 4 pi over 7 g plus 1, and then the last one is g squared minus 2 cosine 6 pi over 7 g plus 1, something like that. So those kind of factorization using the nth root method, and then roots and coefficient relation or something like that, yeah, that could be there as well. Okay, this is my second anticipation. Yeah, the second question can be from the complex number, I think. Okay, up to here. Sorry, the during the last lesson, yeah, my recording was failed, so that I retake all these, and then during the retake the process, the content is a bit condensed, so that it's a bit shorter now. But I think everything I wanted to say is here. So start hard until the end, and then good luck for you guys. Okay, this is really the last lesson for you guys from me in this year. Okay, good luck. Bye.